Okay, we're talking about 2.5. 2.5, we were talking about what are called compound inequalities. Okay, compound inequalities. So it's compound inequalities. Now, if you think about the phrase compound inequalities, you learned through language arts what a compound word is. Compound word like firehouse, right? Or wash tub, right? So two words that you can have separately, but you put them together, it forms a new word, right? So that's the same idea with compound inequalities. We're going to have two inequalities. We are going to combine them into one to have one singular inequality. There are two different types of compound inequalities that we are going to deal with. The first one is what we call our AND inequalities. Okay, our AND inequalities. So this would look like this. X is less than 7 and X is greater than or equal to 3. So I'll have that word AND in the middle. So if we think about what this actually means, what this compound inequality actually means, let's think about it in terms of a number line. Okay, so if I throw a bunch of numbers on this number line, let's think about what numbers would actually be a solution here. Because that word AND means that both of them have to be true. X has to be less than 7 and it has to be greater than or equal to 3. So it has to satisfy both of them. So like the number 4 works, right? 4 is less than 7 and it's greater than or equal to 3. 5 works, 6 works. Does 3 work? Well, 3 is less than 7, that's good. Is 3 greater than or equal to 3? Yes, so 3 is going to work. Anything under 3 cannot work. 2.5 doesn't work, right? It doesn't satisfy this inequality. It's got to work for both. So 2.5 doesn't work. 3 is our ending point here, okay? Or we can go higher. Well, let's think about how high we can go. 6.5 works. 6.5 is less than 7. How about 7? Is 7 less than 7? No, 7 is not less than 7. And so 7 is not a solution here. 7 does not work. And remember, if we were going to say that something does not work, is not a solution on our number line, we have an open circle there. So our graph of this looks like this. We've got two circles combined in the middle. Now, anything that this line covers is a solution, is a number that would work for both of these, right? The number 5 works for both of these. If it's an open circle, it does not work for both. It works for one, doesn't work for both, doesn't count, not a solution. Okay, so this graph shows us our solutions. Okay, so we've got that. The other way to write our AND inequality, and this is important because we're going to see this, is we can combine these into one. Now I'm going to have to move around a little bit. So here's what I'm going to do, is I'm going to think about flipping this second inequality. And saying that X is, I wrote that wrong. X is greater than or equal to 3. So 3 is less than or equal to X, right? And that's really represented by this one, right? This dot is that 3 is less than or equal to X, or X is greater than or equal to 3, or X is greater than or equal to 3. That's this part of it, right? Closed circle, arrow to the right. This part of it was that X is less than 7. So what we can do is we can combine these together. We can combine these together to say that X is going to be between 3 and 7. Okay, that X value, right? Our solutions between 3 and 7. It can be 3, right? I've got the or equal to, I've got the closed circle. It cannot be 7. And the less than, I got the open circle. So this is what we would consider a compound AND inequality right here. All right, so if we look at another one, right, we could see -2 less than X less than or equal to 0. Okay, notice when we write these inequalities, you're always going to have your smaller number on the left, your bigger number on the right, the X in the middle. Okay, it's always going to be a less than or equal to sign as we go, because the smaller numbers over here, it wouldn't make sense if we flip those signs. There are smaller numbers on the left. Okay, so if we wanted to graph this, I know before we talked about having 3 numbers down on our graph for compound inequalities, we just need 2. We just need those 2 numbers that are there. Okay, and we got to pay attention to open versus closed circle. This time it's going to be an open circle on the left because that's just a less or a less than sign there. Here's a less than or equal to, so that's going to be a closed circle, and x is in between those two values. So compound inequality, there's our graph for it. Okay, this is our and inequality. This says that x has to satisfy both of those. It's got to be bigger than -2, and it needs to be less than or equal to 0 for it to be a solution. Okay, that's our and. Okay, the second one that we talk about is or. So this one's a little different. This is saying x is less than 4 or x is greater than 10. X is less than 4 or x is greater than 10. So with the word or in there, okay, the way it's worded now is x is either less than 4 or x is greater than 10. So it's one or the other. It doesn't have to be both. It can't be both, right? It's one or the other. So as long as the number satisfies one or the other, it's a solution. So for example, let's get some numbers just so that we can visualize this a little bit. Right, x is less than 4. So that means anything less than 4 is a possible solution. 0 is a solution. All the negatives are solutions here because all of them are less than 4. Great. Or x could be anything bigger than 10. So open circle on the 10, arrow going that way. So anything that those arrows cover right now, that is a solution. It's either one or the other. It satisfies one or the other. So it works. Okay, it cannot satisfy both. That's the and. The and is when it's both, and it satisfies both. The or is one or the other. So with our arrows are going to be going away from each other. Okay, we're going away from each other. It's either this or it's that. And as long as it satisfies one or the other, it's a solution. Okay, so that's our or. And this is the only way that we could write it. We have to put that word or in between. There's no better way of writing. We can't combine it into one like we did with our and. We are going to have to use that word or in our compound inequality. Okay. So this is the first big takeaway, right? And versus or. You got to be able to graph it correctly. You got to be able to write it correctly and understand how the graph represents that inequality. That's important, right? Why is it in together like this? Because that's where the values work for both of them. Why is it split apart? Because those are each one individual. Okay. All right. So that's our basics. And then we need to be able to solve our compound inequalities. So they're going to give us inequalities that we need to solve. Okay, we need to solve and graph. They're not just going to give us stuff to graph. We got to solve first. So here's our first one. It's going to look a little different now. All right, it's going to look a little different now. So we've got, and I'm going to make these or equal to's just because I like the look of it a little bit better. But now I've got this compound inequality. There's two inequality signs within the same problem. We haven't seen that yet. Okay, not in anything that we've had to solve. There's two of them. So the goal here is to end up like what we saw before. Remember, we saw something like this, where the x is by itself and in the middle. So that's what I want. I want the x by itself in the middle. So if we think about what we have to do or what we could do to get that x by itself in the middle, we have to get rid of that -2. To get rid of that -2, we would add 2. But just like with equations, whatever I do to one side, I have to do to the other. But now I just don't have 2 sides. I've got 3 sides. I've got the middle and I've got both sides. So whatever I do to the middle now, I do to both of the outsides as well. So I'm adding 2 to every single part, all 3 parts. When I do that, that's going to cancel out in the middle. I got -2, less than or equal to x, less than or equal to 5. That's my answer. Any number that's between -2 and 5, if I were to take it and plug it in, that would still work. That answer in the middle would be between -4 and 3. So that would be my solution. I'd go to graph it. I got -2, I got 5, I got closed circles on both, and they are connected because x is in between. Right? So for this, we are doing the same thing on all 3 parts of that. Okay? All 3 parts to be able to do it. Okay? Good. Let's take a look at another one. Since this is a video, you know you can always rewind, rewatch. If you didn't catch it, if I erased it too quick, whatever, go back, rewind, watch it again. Okay, get your notes. Let's look at another one. Let's see what we got. See what we got. What about this one? A little bit harder. -3 less than 2/3 x minus 5 is less than 0. Okay, a little bit harder. Here's what I want you to do. I want you to try it. Okay, I want you to pause the video. I want you to try it. See what you can come up. See with it if you can get the solution for this, and then come back and I'll walk you through it. So pause the video and then come back. All right. So here's what we're gonna do. We gotta get that x by itself. So we gotta go backward through the order of operation. So I have subtraction. So I'm gonna add 5 to everything first. And remember, that's all 3 parts of it. So that cancels out the 5. Here I've got 2 less than 2/3 x less than 5. Great. Now I got to get rid of the 2/3. Anytime I get rid of a fraction, I'm multiplying by the reciprocal. Hopefully you remember that. We've done it enough this year. So we're multiplying by 3/2 to every single part, all 3 parts. It's going to cancel out here. 3/2 times 2 is going to give me a 3. Over here, 5 times 3/2 is 15/2. We could leave it like that, change it to 7/2, whatever you like. This right here is our solution. And then we could graph it. Open circle on 3, open circle on 7.5, line connecting. Okay, so hopefully we got that. Now, let's see what happens. What would happen if instead, and I'm just making this up off the cuff here, so it might not work out great. But let's go 4 is less than -2x is less than 0. Okay, let's say we have this. We go to solve. We're going to divide by -2. We divide everything by -2. We got a -2 over here. 0 divided by anything is 0. I got an x in the middle. However, I divided by a negative. And anytime we divide by negative, hopefully you caught that and the red light went off in your head. You divide by negative, you have to flip the sign. So we're flipping both signs here. We're flipping both signs because we've divided everything by negative. So now we're here. Like I said, it's not going to work out very nice for us. I couldn't think that quickly in my head, but we would flip the sign and then we would have our solution. Okay, this one doesn't make sense. Let's take a look at why it doesn't make sense. If I were to rewrite this, because we always want those less than symbols, if I turn that all around, that would be 0 is less than x is less than -2. Does that make sense? No, it doesn't. You can't have a number that's greater than 0 and less than -2. Can't happen. So if you ever ran into this, we would have to say no solution because it's not possible. There's no x value that actually falls in between those two numbers like that. Okay. So sorry for giving you one that's no solution off the gate, but we might run into that at some point. Okay. The important part is if we divide by a negative, you gotta flip the sign. Gotta still flip the sign. Okay. All right, let's move on. Solving an OR inequality. Solving an OR inequality. In this one, when we solve the OR inequality, it looks something like this: 3y minus 5 less than -8. Or they're going to have that word "or" in there. 2y minus 1 is greater than 5. Okay, they're going to give that word "or." You can't combine it into one, right? So since they're separate inequalities, let's solve them separately. We're going to add 5. 3y is less than -3. Divide y is less than -1. Great. We solve over here. Add 1. 2y greater than 6. Divide y is greater than 3. Great. You cannot just say that these are your two answers. Your answer is y is less than -1 or y is greater than 3. You have to have that word "or" in there. If you don't have the word "or" in there, it's not correct. Because we don't know, if you don't have the word "or" in there, we don't know exactly what you're talking about. Y is less than -1, y is greater than 3. Which one's the answer? We don't know. You got to have that "or" in there because it's one or the other. Okay, got to have both parts, got to have the "or" in there. So this one's pretty easy because you're just solving them separately. Okay, nothing special to worry about. Again, flip the sign if it's negative, if you're dividing or multiplying by negative. But it's just solving each one individually, putting the "or" in between. Okay. And then if we wanted to graph that, right? If we go to graph, you just need those two numbers. Y is less than -1, Y is greater than 3. There you go. We got our solution. Okay. I found one that's actually going to work with this flip the sign thing. So we're here. Let me just walk you through it so you can see how it will work out. Get rid of the addition subtraction first. It gives me -4 is less than -2x less than or equal to 8. Divide everything by that negative. So that's going to give me a +2. Flip the sign. Flip the sign. -4. So now when I take that and I switch it around, because I want to switch it around, because I always want the lower number over here. I want less than signs. That would be -4 less than or equal to x less than 2. This one makes sense. Okay, I should have done this one first. This one makes sense, right? X is anything between -4 and 2, including -4, not including 2. And there we go. Okay, so those are our compound inequalities. Again, if you need to, rewind it, watch it again, watch a specific part, take your notes before you start that homework. If you have questions, make sure you're asking. Okay, next time you see me, make sure that you're asking so that we can go over. Okay, there you go. That's it for 2.5.